This video is on determining domain and range, and this is going to start on page 5 of your notes. The domain is a set of input values. For which a function is defined and real. The domain variable is also called the independent variable. Now you guys know that we've been talking about this a little bit, and the independent, or the domain, excuse me, is usually your x value. Is that what you need to use? Okay? Situations that affect the domain. So the question you have to ask yourself is, are you worried? Because if you can't put that in your function, or it doesn't work, then I ask, am I worried? And if it's worried, then you know that you can't use it. So there's two instances, or two main situations that affect domain. One is fractions and one is radicals. With fractions, you cannot have a 0 in the denominator. So if you get a fraction, you know that you cannot put a number in that's going to make the denominator 0. So if I had 6 over 0, there's no way you could have that. No way. Radicals, and I'm talking square roots, so we're talking just a plain old radical here, you cannot have a negative, let's erase that, have a negative number under the radical. If you recall from last year, like a negative radical 36, that was imaginary. We could write it as a 6i, but it's imaginary, so it's not anything you can have. When you're asked to determine the domain of a function, you should go through the following questions. It is possible to answer yes to more than one question, then you can answer yes to more than one question. You can do this with the work described in all the questions. Okay? So we're going to go through these questions, each one, and you say to yourself, is this function rational or fractional? So you ask yourself, is it fraction? Is it a fraction? If it is, I am worried. Okay? So worried. I'm definitely worried. Okay? Let's go to the next page. So let's practice with some rational functions. So I see this is a fraction, so I'm worried. So this is the technique you're going to do. You're going to take your denominator here, and you're going to put it where you can say it's not equal to 0, because I can't have it equal to 0. And when you do that, I have, sorry about that, that's a 0. X can't equal 5. So if I put a 5 in there, you'd see I'd have a 0 in the denominator, and I can't have that. So when you do a fraction, you basically now have your domain. Your domain, we put a D colon for domain, it's all your real numbers. So I can have any number I want, but I can't have a 5. So we put that in brackets right here. When we do this in interval notation, we do negative infinity to 5, parentheses because it's not included, in union with 5 to infinity. This shows you there's a hole here. That means I can have every number, but I can't have 5. All right? If I was going to do the range of this, in which we're not really doing this quite yet, but if I were to sketch this graph, because all the ranges you can do by sketching, here is a 5. There's really a vertical asymptote there, and the graph kind of looks like this. Down like this, and it comes up like that. So if you see, I can have everything but a 0. There's no way this is ever going to be 0. So the range is going to be all real numbers, but not, I can't have a 0, and that would go from negative infinity to 0 in union with 0 to infinity. Okay? Now let's look at this one right here. This is g of x, and I have a fraction, so I'm worried, so I take the denominator and I put it where it can't equal to 0, because I can't have that. And by doing this, this will give me my domain. Well, here I can factor this. And when I factor it, I get x plus 2, x plus 1. Draw the line. So x cannot equal a negative 2, x cannot equal a negative 1. So when I do this domain, I'm going to come down here a little bit. I do this domain, I can say it's all real numbers, but I can't have a negative 2 and I can't have a negative 1. Now this one, when I write this in interval notation, it looks kind of weird, but you got to skip both of these. So I'm going from negative infinity all the way to negative 2 in union with, now I can have all the numbers between that, negative 2 to negative 1, in union with negative 1 to infinity. So now I have two holes, because at negative 2 and at negative 1 I don't have numbers, okay? So we're not going to do the range on that one right now, but that's how you do the domain. Here I have another fraction. So am I worried? Yes, I am. So I take the denominator, I say it can't equal 0. This one's a little different, because watch, when I move that over here I have x squared cannot equal a negative 1. Well, no kidding it can't. That means I don't have any holes. That means my domain is all real numbers. I can have anything, because this will never happen if I square something. It'll never be a negative number. And how we write that with interval notation is negative infinity to positive infinity. Okay. Now if I were to graph this one, I want to show you this one. This is kind of interesting. If I were to graph this one, this is what the graph kind of looks like. This is 2, and it kind of comes up. Alright? And if you look at it, notice there's no asymptotes in there. That's one indication. And the other thing is you can look at it and say, oh, look at my range. It's interesting. It goes from 0 to 2. It includes 2, but it doesn't touch the 0. So my range in this one is kind of neat. It's between 0. My h of x is between 0 and 2, but it includes 2. So I write this in interval notation like this. A parentheses because it doesn't include 0, and a bracket because it does include 2. Alright? Now, let's look at question 2. Does it have a square root, or a fourth, or a sixth? If the answer is yes, I'm worried. Okay? So what we're going to do is, in this case, what you're going to do is take underneath the radical, and you know it can't be negative. So you know that I'm going to write it like this. 2x plus 3, let me erase this little line here, has to be greater than or equal to 0. So now when you solve for this one, this tells you what you can have. I can have x is greater than negative. This is the domain, so that's kind of cool. So the domain on this one is going to be x is greater than or equal to 3/2, and that would go bracket for interval notation, comma, infinity. And remember, you never have anything, you never have a bracket next to the infinity, because you never get there. Now the graph of this one's kind of interesting. Here's negative 3/2. And the graph of a radical looks like this, and you'll notice there's my domain. The range is everything that's greater than or equal to 0. So I can say k of x is greater than or equal to 0, or 0 to infinity. Okay. Now, real world problems. This one, if you answer yes to this, basically what I want you to remember this is life is in quadrant 1. So here's a big L. Life is in quadrant 1. Because if it's a real world problem, lots of times you don't want to have negative numbers in it because it doesn't make sense, or negative dollars. So basically you cannot, or usually don't have, negative numbers. Okay? So in this case, if you're calculating the number of textbooks sold to make a profit, if I were going to draw this, okay, number of textbooks sold, so here's the number of textbooks sold and here's your profit, if you'll notice, your domain is going to be from 0 to something. Whatever you think it's going to be. You can't really say 0 to infinity, because you can't have infinity textbooks, but I just want to let you know that you usually have to have it in quadrant 1, and so it's usually 0 to something. Or if you're calculating the volume of a rectangular box, you really can't have x. If x is the height, you can't have x be 0, because then it wouldn't be a box. So if I'm calculating the volume with the side that I'm cutting out, again, it's going to be in quadrant 1. Alright, let's talk about range, even though I did a couple of them. The range is the output. It's also called the dependent variable. And remember, we use y's for this, or f of x. So usually this is your y values on your graph, or f of x if you're looking at a function. Now, when you find the domain and range graphically, okay, basically you're looking at how far left and right does it extend, because you're looking at the x-axis because it has to do with x's. So you're looking at it how far left and right. The domain is given in only terms of x values. All right. The range is how far up and down the function extends, so you're looking at the y-axis because it's your y values are used. Right? Now, I have some actual pictures of the functions we just did. So you can look at the domain is left and right, and here we notice we had a 5 there before, and the range is bottom to top. Okay, and we said we couldn't have 0. This one is left to right, and then the range here looks like from 0 up. So here's the range here. It goes from 0 up. It doesn't actually touch 0, so it's like open here. And then it goes from negative 20 down, and it includes negative 20. Okay, oops, I'm sorry. So let's go back. So let's look at the one here on the bottom. Find the domain and range of this one graphically. That was the one I showed you before, and here's the radical that we did before. So these are actual pictures, and we're going to practice more in class. So there's a little basics of domain and range, and I will see you in class.